Okay, so welcome to week 3 of the IEEE ACE group CAD 3D printing. I'm going to share my screen. Okay, so this week we're going to be doing, last week we did the basics of Inventor as a whole, and we made a part. This week we're going to be making drawings, assemblies, and presentations. So parts are, or .ipt in Inventor are the fundamental pieces for all the other files. So we have there listed there parts, assemblies, drawings, and then presentations. So drawings or .dwg is a standard file across all of or most of Autodesk programs. I know that one time I'm on the solar car team and we created a dashboard panel and we used the text that we put on the panel in Inventor. We took that, turned it into a .dwg file, and moved it into AutoCAD Electrical, and we're able to edit it there as well. So these files can go back and forth. And what it is, as you can see there, it's an annotated document. And on the right, it shows all the different formats. You have templates, and this is so you can show, a manufacturer or even your customers or just someone who needs more information about the part, all the different views and dimensions of it. So some of the basics. So before you do anything, a lot of the title block in the bottom right will automatically fill out as you move on, like certain fields. So before you even do anything, it automatically fills in the drawn by section with the user. So I'm NP Halkias, and then it also fills in the date that it was created. So then at the top of the screen, you have the place views and annotate tabs, the two different ribbons. Place views would be to, as you can see there, place your base view. Then you can have all your other types, which we'll get to when I move into Inventor. And you always want to start with the base view because that's how all the other views are. All the projected view, the auxiliary view, they're all based off your base view. And then inside drawings, they don't have the same options as parts or assemblies. So like last week in a part, when we wanted to change the units from inches to millimeters, we just went to document settings. However, for a drawing, you have to go into the application settings, application options, in file, and then again, I'll do this when I'm inside Inventor as well. Configure default template, and then you pick between inches or millimeters because those are two standard units. And then you can also change the dimensions of your text size. So again, I'll do this in Inventor. You go to the Manage tab, Styles Editor, click the plus sign next to text, and this is note text, and you can just adjust the text height. So this is more here just for your reference if you ever go back to this slideshow for information. So the basics of creating a drawing. So assuming you have already made a part, you would click base, as I showed before in the top left. You would select the part that you want, and then this window in the bottom left would show up. You can label it, change the scale. And again, it's important when you're setting your scale to also keep in mind any extra space you might need for all the views you want and all the dimensions you want to include. And you'll notice in the picture in the top right, you can see that right up against the main drawing in the bolded green box, it has like a bunch of gray arrows coming out of it. You can think of those as like quick views. And again, I'll go more into detail when I'm in Inventor with that. But you can easily create more viewpoints just by clicking and dragging your mouse. So now we're going to do a quick example with creating a drawing. So this is the part we created last week, the fixture block. So I'm going to go to the home page. And I'm just going to click new drawing. You could also go here to new, pick from here. So you can go standard. I'm just going to use the basic template, create that. So now it's just going to be this blank sheet with your title block in the bottom right. And as you can see, it's already filled out my name and today's date. So first thing we're going to do is we're going to, again, choose our base view. It actually already picked the fixture block, I'm assuming because I already had it opened. If you didn't want the fixture block, you can click the open existing file and you can pick from your saves. But given that I have my fixture block right here, I'm going to change the scaling. Just click and it will scale it down for you. Now, what I was talking about before about creating quick views. So notice how when I move my mouse to the right, this green box appears. Now, before you click, this wouldn't really make much sense. But when you click, it gives you the right view. And if I were to bring my mouse up, it would give you the top view. And the same if I went to the bottom or to the left. Now, if you go diagonally, this is how you get isometric views. So if I go diagonally, this green box appears and I click and it gives me the isometric view. And let's say I just wanted to label it, I'll label it front to start because it individually labels each one, but this label refers to the base one. So when I click OK, it's already see front. When I hover over front on the left here, it highlights that view in red. And it's already giving me some dimensions, but they're a little messy. They get the job done, but they're a little messy. You can click and drag them out. Now notice how small the text is. So what we're gonna do is we're gonna change that. So what you're gonna wanna do is you're gonna wanna go to Manage, Styles Editor. Takes a second to load. Again, you're probably gonna be up here in Standard. You're gonna wanna go down the list to Text, expand it, and go to Note Text. And we're just gonna change the text height to 6.1 millimeters. Just gonna save and close that. And now our text is bigger. And now with all our different views here, we can annotate it. So this again is if you're going to give this part to your supervisor or just for your own reference, you would want to put certain dimensions. So if you wanted to mark, this chamfer that we made, you would click dimension, click the corner, and then you can either do diagonal length, horizontal length, or vertical length just by moving your mouse around. Inventor automatically does it for you. So I'm just going to do the vertical length here, and I'll do the horizontal length here. And then if you wanted to make, the whole dimensions, you just click on the edge of the hole. Same thing with this arch. It automatically tells you these dimensions. And then if you wanted to fill in the title block, you would just do text and start filling in the title block as you see fit. So this is the basics of a drawing. If you wanted to create other views without using the base view, you can change it just from here. So if you wanted to make your own isometric view just based off the base view, you can just adjust it this way. I just find it easy to do the quick views at the start. But that's it for drawings. Very simple, very straightforward. It just gives information about your part that you created. So moving on, we're going to go on to probably the coolest part about Inventor, which is assemblies. So in assembly, as you can see by the descriptions, it's taking all of your parts and putting them together so you can actually make, a contraption, some machine, mechanical, electrical, or otherwise. So you have a standard assembly, which is just taking parts and putting them together, whether it's, shafts or pulleys or nuts and bolts, whatever. Or you have a weldment, which is specifically made for parts to be welded together. It's not joined by nuts and bolts, screws, whatever. It's specifically welding. For our example, we're going to be doing a standard assembly, not a weldment, but again, you had that opportunity. So some of the basics. Um, for any personal project that you're making, for whatever you are making, you will probably never have to leave the Assemble tab, and then you'll probably never have to use anything more than the Place tab and the Joint and Constraint tabs or tools. If you have to use this program for more official reasons, formal reasons, you might have to use more. But for any personal projects, you're never going to have to use more than those four things: the Assemble tab and then the Place, Joint, and Constraint tools. Joint and Constraint are very closely related, and again, when I go into Inventor, I'll be able to explain the difference just by using the tool information it gives you. But Autodesk understands how closely related they are and how confusing they can be at first. So they have a whole help page dedicated to this, which I linked it here. Again, if you're going back for information, you can look here. So creating an assembly. So again, you're most likely going to be using your own parts, so you won't have to use from the Content Center or any other CAD files. You just have your own parts already in your save folder. So again, in the Assemble tab, you would use the Place tool, and it would just open up your files and you just select the parts you want to use. You do have to place at least 2 parts in order to start really doing anything useful with the assembly. I recommend, unless it becomes very crowded, I would recommend just putting all of your parts on the screen. Just have them all laid out instead of constantly having to go back and forth to place. And then based on the complexity and desired movement and design of your assembly, you're going to have to use joints or constraints. And again, if you want to know more information that I'm going to explain, the last slide has that help page from Autodesk. And Autodesk also has a more dynamic example, but I'm going to do my own example right now for creating an assembly. Again, so last week we created this fixture block. I went ahead and created very simple other parts just to make an assembly example. So again, you could just click assembly, or you can go to new. I'm just going to make a standard assembly. So here we are in the assembly workplace, or workspace, excuse me. So we're just going to click place. You have this drop down menu for other options, but we're just going to use place. Now I went ahead, we have the fixture block that we made last week. I also made a fixture plate and then just a bolt and a nut, really simple. So I'm just going to put down our fixture block, or actually first, sorry. I'm going to first place down the fixture plate. I'm just going to show you why. So it's going to open up like this. You can change the view. What I'm going to do is I'm going to right click and I'm going to place grounded at origin. What this means is this shape is now going to be held in place at the origin of the workspace. It's going to be stuck. We'll just change the view on me, but if we go back here, just manipulate our viewpoint. Now this won't move. It is stuck. I'll show you if I go to place another part, like the fixture block. I can freely move this. I can't freely move the fixture plate because I grounded it at the origin. So now I'm just going to go back. I'm just going to place the rest of my parts. Okay, so now we have all of our parts in the workplace. We have the plate that is grounded, our fixture block, and then our nut and our bolt. So now what we're going to do is firstly, we're going to start with a constraint. So a constraint, it controls the position and behavior of components. And then it gives you some examples. A constraint, in order to get your desired outcome in a more dynamic assembly, you're going to have to use a lot of constraints. But a joint is a little different. A joint uses the same general idea as a constraint, but it also determines movement. It helps a lot more with movement than standard constraints. They're very closely related, but again, you'll see like the differences between the two. So I want to create a constraint, and you have all these different types. You have mate, angle, tangent, insert, and symmetry. What I want to do is I want to take this fixture block and place it on top of the fixture plate with the holes lined up. So I'm going to want to mate them because I just want them to be touching each other. So what I'm going to do is, and I specifically want, I don't just want them to be on top of each other, I want the holes lined up. So I'm going to mate them in reference to the holes. So I'm going to make sure you can select either the top hole or the bottom hole. I want to select the top hole. So that's my object 1 over here in selections. I still need my object 2. I'm going to go look underneath. I'm going to select this bottom hole. And now they're mated with each other. I'm going to click apply. And now if I get out of here, they're together. This won't move. But now, I'm sorry, wait, that is strange. That wasn't happening yesterday when I moved it, but I'll show you what's also going to happen now. So if I take my bolt, now with the bolt, I want to go in here, but I also want to be able to take it out and just on a more like cylindrical path. So I want this to be able to move a lot freely, so I'm going to use a joint instead of a constraint. So right now it's set to automatic based on what we select. So I'm going to, again, I'm just going to select this right here. You'll see why in just a moment, and then place it right here. So right now it's set to rotational, which means it will only rotate. I'm sorry, I just clicked and dragged it. Okay. These things weren't happening yesterday. I apologize. So right here, again, click here. Just based on where I want it to be lined up with. I want the bottom of the head of the bolt to be lined up with the top of the fixture plate. And then here I'm just going to change it from rotational to cylindrical. And we have all these other options. You have a slider or rigid, which means it won't move or it will try not to. Slider, so if you had like a piston-like mechanism, if you have a planer, if you just want it to move along a plane, or a ball, it's like a ball and socket joint, we want a cylindrical, so it will show you the movement. It's going to over-exaggerate the movement, but if you want to limit it, you go here to limits. So it has angular and linear limits. We don't really have an angular limit for our bolt. It's just going to spin full 360 when we move it. But if we want to make a linear constraint, we're going to have to make a start and an end point. So first of all the time, the positive and negative direction isn't always evident, so you can just put in a number for the current. So the positive direction is down in this case. So that means we can make our start point at 0, and then we can make our end, we can make it like negative 70 millimeters. So now, you'll see if we apply this, when we get out of the joint menu, we can, I'm not sure why the fixture block is moving. I did this yesterday and the day before, and it wasn't moving like that. It was only rotating around that point. It wasn't moving the whole piece. I'm sorry. Okay. Anyway, so as we move this, so actually this is a good way just to show you the dynamicness of Inventor. So we set the constraints so that the bolt would only move within the fixture block, which it is. And as we move it around, it messes with the fixture block. So this isn't what I wanted it to do, but it's just a good example to show you what is possible. So I'm just gonna hit, what I did there was I just undid my movement. So I can move whichever I want and then just undo and it puts it back the way it was. Next, what we're gonna do is we're gonna put the nut on with the same joint, strategy. So we're just gonna click here, look underneath, and we're gonna attach it right there. And again, at first it's just set to rotational, but I want to actually be able to take the nut on and off. So I'm gonna use cylindrical. And again, right there, it's doing its job. Limits. We want, again, linear limits. So actually, this green arrow is the positive direction, I believe. So if we go to current and do, yeah. So again, we want our start to just be 0 because that's the base point. And if we want this to be the end point, let's just say make it 40. And if we just want to see where that would end up, we can put 40 in the current. It just shows that it goes down to here. And just apply. So here we have our full assembly. Again, we can take off the nut. We can go up here and take off the bolt. And again, it's moving the fixture block. I don't want that to happen. I'm not sure why that's happening. Maybe I can set another constraint, mate, and I want to select this face and this face. And now, yeah, okay, so there you go. I didn't have to do that yesterday, but now it'll just rotate this way because it's mated. The two circles where they meet over here are mated, and now the bottom face of the block and the top face of the plate are mated. So now it'll only rotate. And this is also how we can take the bolt out and we can put the nut back on. Again, I'm not sure why that was giving me issues. It was not giving me issues when I tried this twice before, but that is how you would make an assembly. You would just, again, for personal projects, you only really need to use the place, joint, and constrain tools in the assemble tab. So now we have drawings and assemblies out of the way. So the final, and probably, again, for personal projects, you'll probably never use presentations, but they are very useful in a more professional or like official setting. So there's only one option for a presentation, and what it is, it says right here, it creates an exploded projection of an assembly, and you can use it to create animations as well, and we'll get to that later. So the second you open up the presentation file, it would immediately prompt you to select the assembly file you want. So like in an assembly, it loaded you in, but then you had to click place and select which parts you wanted to use. With presentations, it automatically opens up the menu and makes you pick an assembly right away. And again, the most useful thing in presentations is that you use the tweak components tool. And when you use the tweak components tool, as you move your components, that's what tweak components is. You can see how it looks like it's a move tool with a block. As you move it, Inventor will automatically record your movements and store it in the storyboard, which I'll show you in a minute. So now we're going to do a quick example. Presentations are not hard. They're just taking an assembly and showing, again, making a presentation on how it works. So if we go back to home, we want to make a presentation. Again, it'll immediately prompt me. I already made an example. We have our fixture assembly right here. I'm going to open it. So now it opens up like this. We have our presentation tools up here. Down here, we have our storyboard 1. Nothing is done yet, but then we just have our assembly right here. So what I want to do is I'm going to use tweak components, and you'll notice, so the duration here, I'll get to in a second. So I'm going to click the nut, and I'm going to drag it down. Oh, sorry, so I can just go like this. So now that movement is recorded in a 2.5 second duration. So I'm just going to click OK. And now down here, you notice that now we have this green bar with 2.5 seconds. So if I clicked play, it's going to play me pull the nut from the bolt. And we can see it from different viewpoints. Oh, that's not what I wanted. I want to see it from this viewpoint. Click play, and it shows it. And now if we wanted to take off the bolt, again, to be components, just click it and drag it up. And then click OK again, and now it adds another 2.5 seconds. My microphone just disconnected, sorry about that. So now we have this view, we click play, it'll show me first taking off the nut, and then the bolt. And that's pretty much it. And if we wanted to tweak components, take this and slide it out this way, just to show what's going on here, we can do that too. And then click OK. And again, another 2.5 seconds was added on, and we just show. So the nut would come off the bottom, then the bolt, and then we would slide the fixture block out. And this is, again, just purely to show how your assemblies are made. It's not overly complicated. It's just a really neat tool that Inventor has for your assemblies. So again, we started with this part. We made a drawing of it. We then made some other parts to go with it. Again, no real rhyme or reason to them, just to show you how an assembly would work. And then we were able to make a presentation with it. So just to finish up here, something that's really, we wanted to show you guys. So the whole point of this is to also introduce you guys, to like bring a project to the members. So what we're thinking about doing is doing a drone design project. There's nothing electrical about this project. It's purely to design a modern or futuristic drone. More information will be given in the coming weeks. This is purely just an introduction to get you guys thinking about it. So the whole point is to utilize your knowledge of Inventor, which we've done the past 2 weeks, again, practicing. I can't really go through every single tool, that would be kind of redundant. Also, it just helps more to get practice, hands-on practice, than just watch someone create models. So you will need to make parts, assemblies, drawings, and a presentation of your drone, just to use all the different aspects. The project phase is set to start in 3 weeks from today. So the next 2 weeks, Kevin Morales will take over and do 3D printing lessons. And then that'll be next 2 weeks. And then the week after that is when this project phase will start. But we will continue with lessons because the project is not required. It is just recommended. But if you don't want to do a project, we still will be doing lessons and giving help during the project phase. So just for now, start thinking of designs, and if you would like to work solo or with a partner. And we'll give more information in the next 2 weeks. And just so you guys are aware, at the end of every slideshow, I have the WebEx recording. So this is how you access the WebEx recording link through the Google Drive folder with all these presentations. At the end of each presentation has the link to the WebEx recording. So that is it. I'm just going to stop sharing. And do any of the present members have any questions in general about the program, anything we did today? You can raise your hand, type in chat, wherever.
I have a question.
Yes, Carlos.
Well, you don't mind if I mention this to my group as well, so that we can kind of get more people to participate in both?
Yeah, no, that's great.
Okay. Yeah. Okay, great. I'll mention this to my group at at my meeting today, and I'll definitely tell them about your project that idea that you got, and try to kind of combine.
Yeah, and yeah, for Ethan, Adrian, and Jose. So Carlos is running the AI machine learning ACE group, so he's also going to be doing a project. You can plug that in now. That's fine with me if you want to. If not, you can also attend his meetings if you're interested. But yeah, just that was just some background. So does anyone have any other questions? None right now. And again, I fully support giving feedback, no matter how harsh you might think it is. This is the first time we're doing this whole thing, so criticism is criticism. I won't take it as harsh. We're just trying to make this as best as we can. So if you have any feedback, that'd be great also. If anyone's typing, I'll give it a little extra time. No, okay.
Also, well, yeah. Also, just to add on about what Nick said. So yeah, it's in the sense where I know that Nick and Kevin they're doing a drone project, but I was actually talking to them before about, doing the same thing with like vehicles, with like mini RC vehicles. But this probably won't occur till like next semester because of budgeting. But in the sense where, definitely in the sense where if you participate in either like embedded or AI or even Nick's group as well, is in the sense where like you can just combine all that information and then develop your own thing next semester or during the summer. I'm still having my meetings during the summer, but I don't know what Nick's doing, so I'm not gonna speak out for him. But in the sense where just like keep practicing and develop so that you can start developing your own stuff. Yeah.
Yeah, and that's a good point because I kind of said it before and I mentioned it last week. Especially when learning certain things like a CAD program, I can show you like the basic ideas and premises for like each aspect. So like, why do we use drawings? Why do we use assemblies? Um, but at the end of the day, a lot of this stuff is just you have to hop in and just experiment. What does what works? What order do you have to click things? Because that's different between programs. So definitely like what Carlos said, practice is very important. So again, in the last presentation, we had a link to some uh, just miscellaneous models from Autodesk just to practice. The fixture block was one of them. I recommend just hopping in there, picking a model if you have like an hour and just try making it. Um, Again, it's just practice and maybe then make a couple of your own side parts and then try to make an assembly or whatever, just to get used to the program. I'm sorry, Carlos, were you gonna say something?
Oh no, I just had another idea that our groups could work on together. So I was thinking like in the sense where we can work on making a lidar. You know what that is?
I do not. What was that? Sorry.
So a lidar is it's like a laser sensor that is like outfitted on top of like autonomous vehicles like Tesla and all that stuff. And it uses like laser distance ranging to kind of like
Oh,
something like that in the sense where when I was working with a professor, so I was actually working on the programming for the LiDAR, but he was actually the one to actually create the design, the actual design in CAD. But I know he didn't do it in Inventor, but regardless or not, he was able to do it in CAD. He was able to make like multiple designs. Like he actually went through like 5 or 6 designs on CAD until he found one that was really like small enough to, but in the sense where like you can combine both concepts as well into LiDAR and then definitely make like more complex structures or something like that. It's just an idea just to play around with because in the sense where While you're practicing your skills, you kind of want to also have an end goal, like what do you want to do in the end, or what kind of thing you want to accomplish. So it's just, I'm just throwing ideas out there. I'm definitely going to throw out these ideas to my group as well, but I'm just throwing them out there to your group just to, kind of have, just expand your thinking about, what you can do with 3D printing and all that stuff. It's great. Sorry for interrupting.
No, 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 that's good. No, it's useful because again, it's we offer projects just as like a way to like show what you've learned, but definitely just doing and just expanding your horizons and doing quote unquote random projects is definitely a good way to learn. So I appreciate that. O- Okay, so if no one has any other questions or feedback, that is going to be the end for today. And again, the next 2 weeks we're going to be starting 3D printing with Kevin. Um, so if you want to know more about the 3D printing aspect, or, yeah, 3D printing, definitely want to come the next 2 weeks. And we'll be sending a follow-up email with all the information. So that's it. Thanks everyone for showing up. I'm going to stop the recording now.